Alright, this is Math 7, Chapter 4, Lesson 5. We're adding and subtracting mixed numbers today, right? So if you look at a little sample here, we're looking at numbers that are not just a single fraction, but they have that whole number in front, which is why they're called mixed numbers, right? So we're adding and combining mixed numbers, and we might be subtracting them as well. So, same concepts remain from before, where we're looking for common denominators and then working from that to solve these problems. So on this first one, we have 8 something or other plus 11 something or other. If I was estimating, I would say 11 plus 8 is 19 and a little bit more. I should get an answer that's probably pretty close to 20, just on estimations. But let's take a look first of all at the fraction. What I like to do is just separate the fraction part first of all. So I have really 5/12 plus 1/4. Okay? So this is really taking it back to the previous lesson. So to do this, I want to have a common denominator. I'm going to go with 12. So the 5 stay the same. To turn this into a 12, I have to multiply 4 times 3. So I'll multiply the top number by 3 as well. So I end up with 1 times 3 is 3 for 8 twelfths. Right? So I add that up and I have 8 twelfths. That can be reduced by 2 divided by 2. 8 divided by 2 is 4. 12 divided by 2 is 6. I can still divide that by 2 again. And I end up with 2 over 3. Now I'm not done because that is just the fraction component, isn't it, right? Those parts. So now I can combine the whole numbers. 11 plus 8 is 19. And I have 2/3 right here. Sometimes when you're doing this, you might have to increase that whole number value depending upon how the fraction part came out. And I'm sure we'll see some of those as we go further along. So if this had been an improper fraction where it was 4 over 3, I turn that into a 1 1/3, and then all of a sudden this has to be added to the 19. I'm sure we'll see some of those in a moment. Let's keep on going. On number 4, I have a 9 whole number minus a 2 whole number. No big deal there. But my denominators, I need those to be the same before I can combine them. So we're going to go with a 10, because 5 times 2 is 10. So I'm going to do 2 times 4 on the top. 2 times 4 is 8. I keep my minus, so minus, and then this one stays the same because I already had a 10 on the denominator. So I have 8 minus 3. Well, 8 minus 3 is 5. Denominator stays the same. And 5/10 is actually equal to a half. So that's my fraction component. The whole number is 9 minus 2. 9 minus 2 is 7, and I keep the half like it is, so I have 7 1/2. Let's look at number 6. On number 6, I already have a common denominator. That's handy. So again, not worried about the whole numbers quite yet. Let's look at the fraction part. I have 1 minus 3. Now, this one poses a little bit of a problem because I really can't do 1 minus 3, at least not that I know of. So if I did 1 minus 3, I'd end up with a negative 2/5, right? If I did my normal type of things of doing things. So a negative 2/5. Well, that's a little funny because if I put that back together, I would have 9 minus 2 is 7, right? Let's pretend here. So 7 and a minus 2/5. Well, if I do 7 minus 2/5, then I'm not really done yet because that's not combined into a simplest term. I still have more work to do. I have to take away 2/5 from 7. So that's not going to quite work out. So there's probably a better way of doing this here. Let's take a look. If I'm going to have 1 minus 3, my problem right now is that I don't want to end up with a negative answer. So what I'm going to do, in just my case here, I'm going to borrow a portion of the 9. I'm going to take the 9 and turn it into an 8. And by doing that, I'm going to add 5 more to the 1. So 1 plus 5 becomes 6. Okay? So now I have 6 minus 1/3. I'm going to erase this for now because it's going to give me a different solution. So this fraction became, instead of 1/5, 6/5. That's because I borrowed 5, the denominator's value, from the whole number right there. 6 minus 3 is 3/5. That number I can handle. It's positive. So let's now do the subtraction of the whole numbers. 8 minus 2 is 6, and I just put the 3/5 with it. So I have 6 and 3/5. If I think back to my 7 minus 2/5, that's actually the same thing. Because if I'm going to have 7 and I take away 2/5, I'm going to go less than 7, which is 6, And when I take away 2/5, it leaves me with 3/5. So it does work out, but it's a little bit more complicated. So these problems, just take your time with them, and you'll do all right. Let's look at this next one. It may be the same thing. Let's see. Here I have 6. This is a 3. So I want to make it into a 6. No problem. So this is times 2 gives me 6. 1 times 2 is 2. Looking ahead, what would I have? I'd have 1 minus 2. I don't want to do that. So I'm going to turn the 14 into a 13 in order to add 6 to the numerator, which is actually going to be now 7. Okay, so let's rewrite this now. My whole numbers. I have 13 minus 7 in the whole numbers. Am I okay with that? Sure, that equals 6. For the fraction, I now have 7/6 minus 2/6. Denominator is the same, so I just do the math. 7 minus 2 is 5. So I end up with 6 and 5/6 for my solution for number 8. Okay, number 10. If Juliana and Brody hiked both the trails listed in the table, how far did they hike? So we have 3 2/3 and 2 5/6, and we're going to add those things up. So here's 3 2/3, and then 2 5/6. The addition ones are just much easier. You don't have to do this borrowing stuff like we did in number 6 and 8. Okay, so we're going to find a common denominator, and we're going to add these up. So let's do the 2/3 plus 5/6 by themselves. Okay, not worrying about the whole numbers quite yet. The denominator that would be in common would be a 6. To go from 3 to 6, it's times 2. 2 times 2 is 4. So now we're going to add 4 and 5 to get 9/6. That's improper, so let's fix that there. That actually becomes 1, because there's a whole 6 inside of there, and 3/6. 9 minus 6 is 3. I can reduce that down still to 1 1/2. That's, though, just adding up the fraction part. I still have to add the whole numbers. 3 plus 2 is 5. But I have to add 5 to a 1 1/2. So 5 plus 1 is 6, and I keep the fraction as a half, so I end up with 6 1/2. Number 12 down below. Karen wakes up at 6 o'clock a.m. It takes her 1 1/4 hours to shower, get dressed, comb her hair. Takes her ½ hour to eat breakfast, brush teeth, make her bed. At what time will she be ready for school? So we're going to be combining these things here. We have 1 1/4 plus another ½ of an hour. Okay? So our common denominator, we're going to go with 4. Let's make this into a 4. So that's times 2. 1 times 2 is 2. So I have a whole number. And then 1 plus 2 is 3. And the denominator stays the same at 4. So I know the total time it takes is 1 3/4, but it asked what time will she be ready for school, right? So we started at 6 o'clock. We're going to go a whole hour. That's going to make it at least 7 o'clock. And then we're going to go 3/4 of an hour. Well, the way a clock works, right? Think about your time. Here's 12, 3, 6, and 9. 3/4 of an hour is going to get me all the way around here to the 9, which is 45. So 45 minutes is the 3/4. So she's going to be ready at 7:45 is where she'll be ready on that one there. Okay, let's look at some of these extra practice ones on page 305. Alright, this is a great one, number 22, because I don't have a fraction to work with here. Okay, I have 13 minus 5 5/6. So 13 minus 5 5/6 might trip you up a little bit. You might be thinking, well, what am I going to do? There's nothing there. I don't know. Well, that's okay. I don't always need a fraction to subtract, because in this case here, I have 13 minus 5. Well, what is 13 minus 5? 13 minus 5 is actually 8, right? Can I leave it at 8? Not quite, because I have to go a little further. I have to get rid of the 5/6. So I really can't do that. I probably want to have a fraction, don't I? So, like last time, let's borrow something here. Instead of having 13, let's turn this into 12, and then we'll make our own fraction, 6/6. Because 6/6 is 1, and 1 plus 12 is still 13. So really, nothing's changed. I have 12 and 6/6 minus 5 and 5/6. This one's kind of nice because with the denominators being the same now, and this number being greater, I can just do 6 minus 5 for the fraction part, and I'll be okay. But let's go ahead and do our whole numbers. 12 minus 5 is 7. And then 6 minus 5 is 1. And the denominator stays the same as 1/6. So a great little problem, having to borrow from the whole number essentially to turn it into a mixed number. Looking at number 24, another subtraction one, right? So we want common denominator. We have 10 and 4. Well, I'm not going to be able to use 10 because 4 times nothing gives me 10. So I'm going to go with a denominator of, let's go with, ready for this? 20. Why 20? Well, because 10 times 2 is 20 and 4 times 5 is 20. That's why. So on the top, I'm multiplying by 2. 3 times 2 is 6. And we're doing 6 minus, well, 5 times 3 is 15. Already we can see I'm going to have an issue here, aren't I? I'm going to have an issue because that's going to be too small. I'm going to get a negative number. So because I don't want a negative number, let's back up a little bit and let's borrow from the 4. Let's turn the 4 into a 3 and then add 10 to this number. The denominator is 10, so 10 plus 3 is 13. And now we'll do 13 times 2, which is actually 26. Okay? So what we did, back it up one more time, instead of a 4, we reduced the whole number to 3. We added 10 tenths to the 3 on top here to give us 13 tenths. Because we're multiplying by 2 to give a common denominator, 2 times 13 is 26. Alright, now moving on. 26 then minus 15 equals 11. Okay, that equals 11 over 20. But that's just the fraction part, correct? I still have to play with the whole numbers. I have 3 minus 1, and 3 minus 1 is 2, and I keep the fraction like that it is, 11/20 right there. Okay, number 26. The length of Alana's hair was 9 3/4 inches. After her haircut, the length was 6 1/2. How much does she have cut? So we had something, we took something away, and we're seeing what's left. So our problem is essentially 9 3/4 minus 6 1/2. Okay, let's get a common denominator. I'm going to work with this side here and turn it into a 4th, because that's a 4. To go 2 to 4, it's times 2. 1 times 2 is 2. This is nice this time at least, so I can do 3 minus 2 is 1. So I'm going to say the same as a 4. And now I can do the whole numbers. 9 minus 6 is 3. So we have 3 1/4 inches for number 26. And let's look at number 28. Marguerite made this jewelry shown. If the necklace is 10 5/8 inch longer than the bracelet, how long is the necklace? So what it's saying is this necklace from here to here is 10 5/8 longer than what's there. It wants to know the whole thing, which means we're going to be combining those two pieces together. To combine that, I need a common denominator. This is a 4. Let's turn it into an 8, right? So to get to 8, it's times 2. 1 times 2 is 2. So this can be rewritten as 7 2/8 plus 5, 10 5/8. So 7 plus 10 is 17. And then 2 plus 5 is 7. And the denominator stays the same. So I leave it at 17 7/8 right there. Okay? And I'm going to stop there for now. That's enough for this day. So good luck on the rest of them. Again, look in the back for the odd solutions and see how you're doing. Thanks.